Solving systems of linear equations by matrix methods. How to use matrix to solve linear equations? We have various methods. So we are discussing the Gauss-Jordan method to solve linear equations. Let me tell you, short basic or background. We have Gauss elimination, Gauss-Jordan method, because this has come from Mr. Gauss and Mr. Jordan. They were working on linear algebra algorithm to determine the solution of a system of linear equations, matrices and inverse finding. That's why they were working on linear equations, and that's how they came to these kind of solution. Basically, linear equations are lines or plane, and then there is an intersection point that we need to find out. In Gauss-Jordan elimination, the step-by-step process is, let us say we have certain equation. Let us take general equation a1x plus b1y plus equals c and a2x plus b2y equals c2. Now these two equations, we need to find out the solution. What is x and y which is common to both of these lines? So how do we write this? We write this as a, x equals b. This is matrix now. We have formed it in a matrix form. What is a? a1, a2, b1, b2. a1, a2 are the coefficients of x, b1, b2 coefficients of y. These are the coefficients. So this capital A corresponds to this one. Then we have x and y, that is, capital X is corresponding to x and y, which are actually the variables. Then we have the constants, c1 and c2. So these are called constants. On the right hand side, you can say c1, c2. So this is the form. So we started with the equation and we actually came down to matrix. That is how we write matrix. So how to find out the solution x and y using the Gauss-Jordan elimination? For that we have this ax equals b. And since we are dealing with matrix, let us do the matrix, use the property, we'll use the computation so that we can finally find out x. So ax equals b. Both sides this is, let us multiply both sides by a inverse. We know that 2 inverse 1 by 2, that is multiply with 1 by 2, 2, you get 1. Similarly, with that analogy, a inverse a is not going to be 1 because these are matrix. It is going to be an identity matrix. So this is the identity matrix. You have x equals a inverse b. Still, identity matrix multiplied by any of the matrix, it always returns that matrix. So x into I or I into x is x. A inverse goes here. So A inverse, if we can find out, if we multiply it with the right hand side b, which is c1, c2, we can get the value of x and y. So this is the whole idea of any kind of matrix method to solve the linear equations or the equation with 3-4 variables. Let us take an example. So we have these two equations. We'll use the Gauss-Jordan elimination method, GJ method you can call it. So just keep an eye on the solution here, but I'm going to solve it for you. First equation is 2x plus 3y equals 0. Now this is a1, this is b1, and this is c1. Second equation is x minus 4y equals 7. So 1 is a2, minus 4 is b2, and 7 is c2. So let us write it here the way I explained you just now. 2 and 1, that is a1, a2. 3 and negative 4, that is b1 and b2. This is a. Now ax equals b. That is what you have to do. X is xy because there are two variables. If the equation would be 3 variable long, then you have to use x, y, z. Now constant is c1, c2, 0, 7. So I told you x equals a inverse b. So basically we are interested in finding out the a inverse. But this a inverse is going to be computed using the GJ elimination, Gauss-Jordan elimination. For that, we have to use the augmented matrix. In the Gauss elimination also we use this augmented matrix. So we'll take the coefficient of x and y here, make a line or a vertical bar, and then we'll put an identity matrix. This is just signifying if I'm able to make the left one, that is 2, 3, 1, minus 4, as the identity matrix, the right one is going to be the A inverse. It is going to be inverse. I told you A into A inverse is identity matrix. So let us multiply the second row with -2, because we want this 2 to be 1, because I'm going to make 2, 3, 1, minus 4 as 1, 0, 0, 1. So best way is to make there are certain ways you can go ahead. So what, this is row 2, this is row 1. So we are changing row 1 because we want this as 1. So we can get 0 at one place. So multiply this row 2 with -2 and add it with row 1. Okay. So let us multiply. I'll just show you what it is going to be in a different color. So this is -2, this is minus, I'm multiplying whole row by -2. This is +8, 0, this is going to be -2. And as I said, we wanted 0 at the place of -2 just now. We did. So let us add it. Row 2 into -2 plus row 1 is going to give you, the first row remains same, 2, 3, 1, 0. The second row becomes -2 plus 2 is 0, 8 plus 3 is going to give you 11, 0 plus 1 is 1, and -2 plus 0 will be -2. This is the first step. Now keep an eye on left hand side because we have to make it as the identity matrix. The second one is 2. Let us make this 2 as 1, 11 as 1, and 3 has to be made 0. So whichever way you want, whichever property you want to apply, row operations you have to do. So the whole row, this second row, if you divide it by 11, we are going to get a 1 in the place of 11. So let us do that, and for that purpose you can also do multiply the first row with 1 by 2 so that you get 2 as 1. Okay, means I'm just giving you ideas. This is just a solution. The logic is we have to make this as identity matrix, so 11 I'm making as 1. So multiply the row 2 by 1 by 11. This is 2, 3, 1, 0. Now I'm multiplying this second row with 1 by 11. So this is going to be 0. 11 by 11 is 1. 1 by 11 and -2 by 11. Now we have 0 and 1 in the second row. Still we need 2 and 3 to be made as 1 and 0. So in place of 2 I need 1. In place of 3 we need 0. So let us make this 3 as 0. So multiply the second row with -3 and add it to the first row. That is how we can get it. So if I multiply the second row with -3, you get 0 here, -3 here, -3 by 11 here, and this is going to be -6 by 11. -6 by 11? Oh, we multiplied by -3, so it will be 6 by 11. I'll just change it. It is 6 by 11. So 2, 0, 1, 1, 0, and we have to add it now because 2 plus 0 is 2, 3 minus 3 is 0, and then we have 1 minus 3 by 11, that is going to be 8 by 11, and 0 plus 6 by 11, it is going to be 6 by 11. Please remember it's 6 by 11, not -6 by 11. I'll just change it because we have multiplied by -3, it is going to change as 6 by 11. So it is 6 by 11, not -6 by 11. Okay, so this is your this first row. Now coming to this is 0, this is going to be, this is 1, this is negative, this is 1 by 11, and this is going to be, this is plus 2, minus 2 by 11, we multiplied 2 by 11, yes. Okay, I'll just change the sign, but we have to think, you have to just go to 2 and make it as 1. So multiply the first row by 1 by 2. Don't worry about the negative sign or plus sign, but just, concentrate upon the logic because we have to make 2 as 1. So multiply this whole row by 1 by 2. So now multiplying, it is going to be, left hand will be all the identity matrix. 8 by 11 multiplied by 1 by 2 is 4 by 11, and 6 by 11 as I told you it is 6 by 11. So 6 by 11 multiplied by 1 by 2 is going to give you, it's 6 by 11, it's 1 by 2, so it is going to be 3 by 11, 6, so 3 by 11 it will be. And so we have got all the values. So let me just write all the values. I'll write it one more because it is going down. So final value I'm going to write 1 0 0 1, and then we have the this vertical bar 4 by 11, 3 by 11, 1 by 11, and minus 2 by 11. So this one is what? This is the inverse. This is A inverse. If you say that this 2 3 1 minus 4 is A, this is going to be inverse, A inverse. Now multiply this with the B, which is actually 0 and 7 here. So let me write it here and show you that this is going to be 4 by 11, 3 by 11, this is 1 by 11, this is minus 2 by 11, and just multiply this by, this is A inverse. Multiply it with 0 and 7. So when you multiply it with 0 and 7, what do you get? You get the final value as 21 by 11 and negative 14 by 11. That is going to be X and Y. So you got the idea, right? It is not about computation. It is about the logic that we have to make the left one as what? Identity matrix. So let us take a proper equation, and I'll just go through it because this is the equation you are going to solve in your examination and in your classwork. So this is x1, x2, x3. We have three variables here, and since we have three variables, we will express the coefficients and the vector of independent terms as an augmented matrix. So we'll take the coefficient of x1, write it in the first column. We'll take the coefficient of x2, write it in the second column. We'll take the coefficient of this one and x3 and vertical bar, and you can put this here also, means the c1, c2, c3 here. So we have to make the identity matrix. If you are able to make the identity matrix, the right one will be the answer. So we have to normalize it because we need 1. So multiply the whole first row by 1 by 3.000. Don't worry about 0.000. So first row I'm multiplying by 1 by 3.0 just to make it as 1. And now I'll use this one to change to make the 0.100 or 0.300, that is the two values of the first column, as 0, because 1 we already got. So we'll multiply the first row with 0.100 and subtract these two rows. Then this R1. Then we will multiply the the first row with minus 0.300 and add it with the third row. So what will be the final result? It will be 100. Now same thing you have to do for the second column and the third column. That is, let me just show you the next step. This I'm just going through. So you have this as, so see, this one is the 7.003. Let us make it as 1. So we divide it by 1 by 7.003. When we multiply it by 1 by 7.003, we will get a 1. So now using this 1, we will make the first row and third row as 0. That is minus 0.003 you have to multiply and then add it to the first row. Multiply the second row with minus 0.190 and then add it with the row. When means second and third row you have to add. After multiplying the second row with minus 0.190 basically. So similarly here also, because now we want 1 in the third way. You would argue, why are you not making 0.068 or 0.042 as 1? Because we need 1 here. So once we normalized it, what we got? We get 1 here. Now same thing, multiply third row with these two values and just add them. So you will get an identity matrix on the left hand side. Right one is your final solution. Okay, this is your final solution. Okay, this is all about Gauss-Jordan method. Thank you so much. Take care of yourself.